Okay, today we're going to learn how to understand predictions using residuals and residual plots. We already know from before that correlation and regression only describe linear relationships. A quick example of a linear relationship is something like this, where the dots all seem to follow a path, a line from the bottom left to the top right. It appears to be linear. Something that would not be linear, example would be this data right here on Gapminder, which has a curve. As it bends, as it goes up, it bends to the right. So correlation and regression only describe linear relationships, like I just said. And we use residuals and residual plots to help determine how well a line will describe our data. We already learned from before that we can make lines, regression lines, using a least squares regression process, which Excel does very easily for us. But we need to make sure that that line that we're making, the straight line, is actually a good description of our data. So we need to understand what residuals are and how to calculate them. Residuals are the vertical distances between the regression line and the recorded data. For example, we've seen this image before. The dots are just data points, and the line going through them is the regression line that Excel or any other program created for you. A residual, like I said, is the vertical distance between the dot, the data, and the regression line. So the residuals in this case are all of these bold lines right here, here, here. The way you calculate what a residual is you subtract the predicted value from the observed value. And we're talking about the y values in this case. So if we go back to this image, the residual for this dot, which appears to have a y value of about 35, would be 35 minus whatever the y value is right here, and the y value right here is about 31. So for this bold line right here, the residual would be about 5. Now we'll practice actually calculating the residuals of a real set of data, and start making the residual plot. What you can see here is I have a small set of data of PSAT scores and SAT scores, and one can assume that how well you do on your SAT could predict how well you will do on your SAT. In fact, we have this scatter plot already made of that set of data right there, with an R value of 0.81, which indicates a somewhat strong, not very strong, but a somewhat strong correlation between your PSAT scores and your SAT scores. Also, what you should notice is I've labeled these this set of data as, the first column I have is the observed X values, because we're saying that the PSAT is a predictor for your SAT score, so that would be your X values, and we're calling the SATs as the observed Y values. Remember, we said to calculate the residuals, it is the observed Y value minus the predicted Y value. In order to get the predicted Y value, first we have to get Excel to give us the regression line. So, as we already know, you right-click on the data, add trend line, and display the equation on the chart. Now we have a trend line, and we also have an equation, a regression line, that is used to predict Y values given any X values. So predicts SAT scores given a PSAT score. To get the predicted Y values, we simply use an equation, this equation in Excel. The predicted Y values in this case are going to be, you type it in as equals 9.9035 times the X values, and X values in this case are the PSAT scores, so you'll click on PSAT, plus 190.62. And we get this predicted Y value, of 1369. So what Excel and what this equation is telling us, this regression line, is that if you got a 119 on the PSAT, it predicts you would score a 1369. we know that that student actually scored a 1360, so their prediction is not that far off. We'll drag this down for all of the values. Okay, you can compare how well or how close they are to each other. An easy way to do that, and what the point of all this is to just calculate the residual. The residual is merely just the observed y value minus the predicted y value. Drag it down, and here we have all our residuals. You can see some of the predictions are really close to what actually occurred, and some are pretty far off. This student, in fact, the predicted score that they would get was an 1804, but in fact they scored a 2010. Our final step, now that we've got the residuals, is to make a residual plot. This is the final step. It will take a little bit. I'll show you how to do one by hand, and then I'll show you how to do it on Excel, which will be a lot quicker. To do it by hand, we're simply going to create a quick chart. We're going to need an X and Y axes. And all we're merely plotting are the residuals for every given X value for all these coordinates along here. So our X values range from about, looks like from 119 all the way up to 185. So we'll have X values that will go 120, 30, so these are our X values. Along the y-axis, we want our residuals. And we can see that our residuals range from as low as negative 264 all the way up to as high as 205. So our residuals down here, negative 100, negative 200, negative 300, and up here 100, 200, and 300. So for our first X value we have 119. Okay, the residual is negative 9. So if we go to 119, which is around here, the residual of negative 9 would be right about there. For the next one, 161, we have a residual of 114, so we have to find 161, and we go up to 114, which is right around there somewhere. For 184, it's 167. Around there. For 185, it was negative 32. So around there. For 138, we have 12. For 173, we have negative 163. For 160, we have negative 25. For 168, we have about negative 4. For 163, we have 205. And the last one, for 167, we have negative 264. About there. We get this out of the way. So we can see our residuals now on this plot. And the idea is we want the residuals to show no clear pattern. Okay, these seem to be scattered all along the residual plot, showing no clear pattern. So from what we can tell, generally speaking, it looks like they fit, a line fits pretty well. The only major concern is that the residuals are really far. Okay, we have some major residuals of negative 264, positive 205. The ideal situation is that the residuals are as close to 0 as possible. To make a residual plot on Excel is a lot quicker. What you do is you go up to the top, you click on Data, and you go to Data Analysis. If you don't have this on your computer, if it doesn't pop up, you need to go to the main menu, go down to Excel Options, and you need to go to Add-ins, and you need to find the data analysis. So on here, it's right here, you just click on Analysis Tool Pack, and then you hit OK, and it will load it into your Excel program for you. So once you have it, you go up, you click Data Analysis, and you go down, you scroll down, and we want the one that says Regression. You hit OK. Once you get here, you'll pull up this screen, and you need to tell it what are the X values and the Y values of your data set. So we'll start with the Y values. The Y values are these right here, the SAT scores. You hit Enter, and you go to the X values. Highlight these and you hit Enter, and what we want it to give us is the residual plots. So you click on residual plots. If you want the residuals, you can click on that as well, and you hit OK, and immediately it will bring you to another screen. Right here, over here on this, you can see the residual plot, which somewhat resembles the one that I had made by hand. And it also conveniently gives us all the residuals. All the same numbers that I calculated before are right here. Remember, the residuals are just the distances between the observed Y values and the predicted Y values. So here's our residual plot. As you can see, there's no clear pattern. There's no curve. The dots seem to be randomly placed all along this line on either side of it. So it seems like a linear fit does work for our data. The only concern, like we said before, is that some of the residuals are rather large, and that is not ideal. To wrap this all up, let's quickly understand why we are finding the residuals in the residual plot. Remember, we're trying to determine if the regression line accurately shows the overall pattern of our data. Okay? For that to be true, we need two things. Two things must be true if the regression line captures the overall pattern. The first one is that the residual plot should show no obvious pattern. Okay? For example, we have this residual plot, a random data set. There is no clear pattern. The dots are scattered all around the 0 mark. As opposed to this residual plot where there is a clear pattern, there's this clear and distinct curve. The other thing that must be true is that the residuals should be relatively small in size. Okay, relatively small means it all depends on what kind of data you're working with. In the Excel that we just dealt with, we had residuals of upwards of 200 or more in some cases, which means that the prediction is off by over 200 points. That's a considerable amount, considering if you got an SAT score of 1800 and you were predicted to get an SAT score of 1450 or 1500, that would be a lot to be off by. Okay, so you have to look at the residuals and you have to analyze and think, are these residuals too large for the data set that we're dealing with?